Guys, now we transform Cartesian plane metric into spherical polar coordinate metric. In spherical polar coordinates, the transformation equation between Cartesian coordinates x, y, z into spherical polar coordinates r, theta, phi are given as x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, z is equal to r cos theta. Okay, interestingly, in first term, if we change the order of theta and phi, mean we first write cos theta, then sine phi, mean I change the term in first term x is equal to r cos phi, cos theta sine phi. The second term y is equal to r sine theta sine phi remain the same, but third term z is equal to r cos theta is changed. When it change into r cos phi, mean if in first term angle of cos is phi, then in third term of z angle will be theta, and if in first term angle of cos is theta, then in term z it must be phi, mean these are in reciprocal form, and same our results will be changed. Now we transform these coordinates x, y, z into x1, x2, x3 and r theta phi into x1 bar, x2 bar, x3 bar. So x1 is equal to x1 bar sine x2 bar cos x3 bar, x2 is equal to x1 bar sine x2 bar sine x3 bar, and x3 is equal to x1 bar cos x2 bar. The transformation equation will be G A bar B bar is equal to, this formula is same for every equation, mean it is just transformation equation of a metric tensor. G A bar B bar is equal to delta A bar delta B bar into G A B, where GAB is a Cartesian tensor, Cartesian metric is equal to 1 0 0 0 1 0 0 0 1, a identity matrix of order 3 by 3. Actually, we are dealing with spherical coordinates, so spherical coordinates are 3 in number, so its corresponding matrix must be of order 3. In Cartesian coordinate, it is orthogonal coordinate system, so we have only diagonal elements. So, and diagonal elements here for metric tensor in Euclidean metric have the coefficient 1 1 1 on diagonal, and all other entities are 0. So our GAB in term of Euclidean metric, as we write in Cartesian metric, it must be dx square plus dy square plus dz square, and if we write it in matrix form, so it will be 1 0 0 0 1 0 0 0 1. I told in row option. Now which number we want to find, which terms we want to find in this equation, where G A bar B bar is equal to G1 bar 1 bar, G1 bar 2 bar, G1 bar 3 bar. Actually we give the variation to this metric tensor G A bar B bar in matrix form. So we write the term G1 bar 1 bar, G1 bar 2 bar, G1 bar 3 bar, G2 bar 1 bar, G2 bar 2 bar, G2 bar 3 bar, G3 bar 1 bar, G3 bar 2 bar, G3 bar 3 bar. Also, as we have here delta A bar. Now first we change the contravariant term, we give the variation to contravariant term, which is A, we give variation to A1 to 3 in first matrix, and again matrix A bar, in this matrix A bar, which is written in covariant form, A bar is equal to delta 1 1 bar, delta 1 2 bar, delta 1 3 bar, delta 2 1 bar in second row, delta 2 2 bar, delta 2 3 bar in second row. No, I am on row 3. Delta 3 1 bar, delta 3 2 bar, delta 3 3 bar. Similarly, we can write this equation, this matrix for delta b, b bar. Actually a and b have no meaning differently. These are just symbolically we write it here. These two terms are just for variation. When we give the variation of these two terms, you look second matrix of delta a bar and delta b bar, being right side matrix of 3 by 3, in both term it is same. So it mean a and b are uh, have no meaning. These are not some specific terms. We can write any a and b, c, I, j, k, what we want. Okay, now as we have delta a bar is equal to, mean this chronicle delta is equal to partial x a partial x a bar. Actually we write it is as a chronicle delta. As you know, in chronicle delta, if these parameters a bar are equal, then it is 1, otherwise it is 0. Similarly, partial x a bar, if we have same parameters, then it is 1, otherwise it must be 0. Okay, now we come to question. Delta 1 bar is equal to partial x1 bar is equal to partial x1 bar, and in bracket first equation we write the value of x1. Actually this x1 is equal to, in our previous coordinate system, x1 is equal to x, which is equal to r sine theta cos phi. So here we replace them with new coordinate system, x1 bar sine x2 bar cos x3 bar. Taking derivative with respect to x1 bar, x2 bar, x3 bar are treated as constants. So x1 bar, derivative of x1 bar is 1, and we obtain sine x2 bar cos x3 bar. Now taking the derivative of the same term with x2 bar mean we are taking derivative of sine x2 bar. So x1 bar and cos x3 bar are treated as constants. So derivative of sine x2 bar is cos x2 bar. So we get x1 bar cos x2 bars cos x3 bar. Now again taking the derivative of the same term x1 with respect to x3 bar, which is cos x3 bar. So first two terms x1 bar sin x2 bar are treated as constant, and derivative of cos is minus whatever the angle is. So we got minus x1 bar sin x2 bar sin x3 bar. So in this case we have taken all three derivatives of first term. Now the other three derivatives of second term, which we have y is equal to r sine theta sine phi, and in new coordinate system we have this term x1 bar sine x2 bar sine x3 bar. Okay, so in fourth term we take the derivative of x2 with respect to x1 bar. Here we have a term x1 bar sin x2 bar sin x3 bar. Actually sin x1 bar is equal to uh, a derivative with respect to x1 bar is 1, and other two terms are treated as constant. And in second term we got derivative of x2 bar, which term in cos x2 bar, and for term 3 x1 bar x sin x2 bar cos x3 bar, we have a result. And again in equation number 7 we have delta 3 1 bar is equal to partial x3 partial x1 bar. We are taking the derivative of third term, which was. Okay, so guys, we are on equation number 7. Delta 3 1 bar is equal to partial x3 or partial x1 bar. Actually x3 is equal to this term is z, which is equal to r cos theta. So we have term partial over partial x1 cos x2 bar is equal to derivative with respect to x1 cos x2 bar, and taking the derivative of same term with x2 bar is equal to minus x1 bar sin x2 bar, and taking the derivative of this term with respect to x3 bar, and we don't have this term in this, so the derivative is turned to be 0. Okay, as guys I told you in previous, in Euclidean matrix we have GAB is equal to G11 12 13 G21 22 23 G31 32 33 is equal to 1 0 0, second row 0 1 0, and third row 0 0 1. As the transformation equation is given as G A bar B bar is equal to delta A bar delta B bar G A B is equal to. Now we take the variation of dummy index A and B. In first term, I keep the B as a B fix and I vary it A, which given in first term delta A and in G A. So I write the variation of 3 delta 1 A bar delta B bar G1B, and similarly in second term instead of A we put 2 and with G to B, and same in third term there is 3 for A. Now again we give the variation of B for first term. I give the variation of first term in first term to B, three variations. Mean in first term I put 1 2 3 for B. In first term I put 1, in second term I put 2, and in third term I put 3. So I get delta 1 A bar delta 1 B bar G11 plus delta 1 A bar delta 2 B bar G12 plus delta 1 A2 plus delta 3 B bar G13. So first term is expand into three terms. Now for second term, which is delta 2 A bar delta B bar G2B, it has three variations again. So its variation with B first term B is replaced with 1, and in second term it is replaced with 2, and third term it is replaced with 3. So three equations are derived from equation term 2, and similarly three terms we receive from equation from term 3, and in total we have 9 terms. Now substituting the values of G11 12 G13 G21 22 G23 G31 G32 G33 given in Euclidean metric on the top of this slide GAB. From the matrix it is obvious that GAB is equal to 1 0 0 0 1 0 0 0 1. Accordingly we substitute the values of these one. Other than diagonal all terms are 0, so we get G A bar B bar is equal to delta 1 A bar B delta 1 B bar plus delta 2 A bar delta 2 B bar plus delta 3 A bar delta 3 B bar. Now we have term 1 G 1 bar 1 bar. Now we give the variation to A and B, both terms are replaced with 1. So we get delta 1 1 bar square plus delta 2 1 bar square plus delta 3 1 bar square. Substituting the values from the uh, second last slide of this lecture, sin x2 cos x3 bar square plus sin x2 bar sin x3 bar square plus cos x2 bar square. Okay, taking the square of first and second term, from first two terms sin x2 bar is common from first two terms, so we put it sin square x2 bar aside from the this bracket, and from trigonometric identity cos square plus sine square, whatever the angle is, it is equal to 1. So sin x square 2 bar plus cos square x 2 bar is equal to 1. So g 1 bar we get 1. Now we start second term, g 1 bar 2 bar is equal to, so in this variation we take a bar is equal to 1, b bar is 2. So on right side of the formula we put delta 1 bar delta 1 2 bar plus delta 2 1 bar delta 2 2 bar delta 3 1 bar delta 3 2 bar, and substituting the values of all these parameters and taking into account the result. Sin when these term first term is multiplied with this one, we get x1 bar sin x2 bar cos x2 bar and sin x3 bar square 3 bar, and in second term x1 bar sin x2 bar cos x2 bar sin x3 bar sin x3 bar square, and from last term minus x1 bar cos x2 bar sin x2 bar, and from first and second term x1 bar is common, sin x2 bar is common, and cos x2 bar is common, and the remaining term is cos square x3 bar plus sin square x3 bar, and these two terms are trigonometric identity, so it is 1. And again next term we got x1 bar cos x2 bar sin x2 bar minus x1 cos x2 bar sin x2 bar, and simultaneously these two terms are cancelled as it is equal to 0. Now for third term, g1 bar 3 bar is equal to delta 1 1 bar delta 1 3 bar plus delta 2 1 bar delta 2 3 bar delta 3 1 bar delta 3 3 bar, and substituting the values of all these terms from first and second term, this term as x1 square sin square x2 bar cos x3 bar sin x3 bar plus x1 bar square sin square x2 cos square x3 sin x3 plus last term is multiplied with 0, and first two terms are reciprocal of each other, so these are cancelled and we get the result is 0. Okay, next we want to find g 2 1. So we replace a with 2 and a bar replaced with 2 and b replaced with 1. So in formula it become, if I took on first 1 1 2 2 3 3, and on lower index it is 2 1 2 1 2 1, and substituting the values of all these parameters which we have found previously, and after substitution this one we got result is equal to 0, and g2 to 2 bar 2 bar mean we are changing the parameters a bar b bar as 2 2 for each, so we get delta 1 2 bar square plus delta 2 2 bar square plus delta 3 3 bar square. So delta 1 2 bar का square is equal to x1 bar cos x2 bar cos x3 bar square plus x1 bar cos x2 bar sin x3 bar का square plus into bracket minus x1 bar sin x2 bar का square. So scaling and applying the results on trigonometric results, we got x1 bar square cos square x2 bar plus x1 bar. So at last after simplification we got x1 bar square, which in previous coordinate can be written as r square. Okay, So guys, last term is of this slide, g 2 bar 3 bar mean we are changing a bar as 2 and b bar as 3 and substituting this on right side, and we'll get the result 0. Now g 3 bar 1 bar is equal to delta 1 3 bar delta 1 1 bar plus delta 2 3 bar delta 2 1 bar plus delta 3 3 bar delta 3 1 bar is equal to 1 3 bar is and 1, we multiply all these terms, it gives the result 0. And g 3 bar 2 bar is equal to delta 1 3 bar delta 1 2 bar plus delta 2 3 bar delta 2 2 bar plus delta 3 3 bar delta 3 2 bar, and multiplying and applying these terms is equal to answer is 0. And g 3 bar 3 bar is equal to delta 1 3 bar delta 1 3 bar plus delta 2 3 bar delta 2 3 bar plus this one. These terms are also in squares, and substituting the values of delta 1 3 bar delta 2 3 bar delta 3 3 bar, and we have delta 3 3 bar is 0. So first two terms are non-zero. Substituting these values in terms of squares, x1 bar square sine square x2 bar is common from this equation, and sine square x3 bar plus cos square x3 bar. Okay, so this result become 1. So get r square sine square theta. Okay, so we have g a bar b bar is equal to g1 1 g1 2 g1 3 bar g2 bar 1 3 g2 2 bar g2 3 bar g3 1 bar g3 2 bar g3 3 bar is equal to, substituting the values of all these parameters, we have 1 0 0 0 r square 0 0 0 r square sine square theta in general for orthogonal g I g equal to 0 if I is not equal to 0. Now guys, we have one equation for you as assignment: transform Cartesian plane metric into cylindrical plane metric. uh, First, some steps are given for you. As we know, the transformation equation between Cartesian coordinates xyz and the cylindrical coordinates r theta z are: x is equal to r cos theta, y is equal to r sin theta, z is equal to z, and r is equal to x square plus y square theta is equal to tangent inverse y over x, z is equal to z. Let x y z is equal to x1 x2 x3 and r theta z are replaced with x1 bar x2 bar x3 bar. Then the above transformation equation will be in the form of x1 is equal to x1 bar cos x2 bar, x2 is equal to x1 bar sin x2 bar, x3 is equal to x3 bar, and on right side x1 bar is equal to x1 square plus x2 square, and second term is x2 bar is equal to tangent inverse x1 x2 over x1, and x3 bar is equal to x3. So next equation we have the transformation equation, as this equation is just like as we have in spherical coordinates. The transformation equation is g a bar b bar is equal to delta a bar delta b b bar g a b, where g a bar b bar is equal to g1 1 g1 2 g1 3 g2 1 g2 2 2 3 3 1 3 2 3 3 bar, and deltas are given as these terms.